Okay, so hello? Hello? Okay, so now it's on. So based on the given, I'm not sure if just now you heard me, but anyway, chapter 1 is that you have the time and amplitude transformation. Okay, and then you are given an equation, plot the signal. That one is second one. And then you are either given a waveform and you are asked to plot the signal based on the time transformation that is given. Okay, so this one is either, just adjust that. Okay, this one is based on the or. Okay, so if you see here, I wrote out two things. You are given a waveform and you sketch the signal based on the amplitude transformation given. Or you are given the signal waveform, okay, and you need to you are given a signal waveform, then you need to find to actually find the equation which is include the time, amplitude and time transformation. So if you see here, okay, the example that I give you is that for this time and amplitude transformation, given equation plotting and so on, it's all what covered in midterm last time. So you have the odd animal signal, and then you have the interconnection of block diagram. You're given a block diagram and find out what is the gain of that block diagram. Okay, and then in the last part here is that given a signal waveform and then find the equation based on the graph. Means that two graphs are given before and after. So based on that, you need to find out what is the M time and amplitude transformation. So this one is based on quiz 1. Okay, quiz 1. So remember, make sure that you go through the midterm and then quiz 1 because I already discussed with you guys for the midterm and quiz 1. So go through the recording of the video recording again, synchronous class, and go through how do I explain the answer. But you should by now already come up with your answer solution based on that discussion during that week. And then, okay, for chapter 2 is that, okay, you have learned, actually explain about the convolution sum. Okay, convolution sum. And then you also did on the convolution integral. Okay, convolution integral. So convolution sum and convolution integral is two different things. Remember, for chapter 1 and chapter 2, you learn that you have the continuous time, you have the discrete time. Same thing goes to chapter 2. You have the continuous time and discrete time. Okay, and this we call it as under time domain. So if you see the underneath here, I write out there's a block diagram. So we call it as a time domain, which is you have the two types of a signal, which is continuous time and discrete time. And based on that, you need to identify for chapter 2. Okay, if it is given a continuous time, what type of convolution do you use? So for continuous time, you need to use integral. Okay, and for discrete time, you need to use the convolution sum. So do not mix up. And how you actually differentiate between continuous time is that continuous time is given by t, and discrete time is given by n. Okay, so do not get mixed up. You should be able to identify, and the way you identify the discrete time is that it's always have impulse signal. Impulses, then you know it's discrete time. Okay, and then also in chapter 2 is that you learn that you have the also interconnection of block diagram. Okay, like on I think on Tuesday we did the revision interconnection of block diagram. So you have multiple block. Okay, so let me just explain a bit on this HT. So you have one signal over here. Okay, you have one block diagram over here, underneath here. Okay, and imagine this is only H1. Okay, H1. Okay, H1. So let's say if cannot drop it. if I rub this off, okay, if I add one more system, H2T. Why? Okay, if you have H2T, okay, so you have two blocks interconnected, and as I mentioned previous revision class is that you might have another one more block, H3T. Okay, so all of this, if you see here, okay, so you have the YT at the end here. Okay, so H1T is also a system, H2T is also a system, and H3T also a system. Okay, so imagine that example, a system is comprised of electrical circuit, mechanical circuit. Later on, when you are third year, you will learn about electromechanical system. So might be in the system you have electrical circuit in the H1 block. And then H2 block is you have the mechanical system. So that is where you can actually combine and get the transfer function. Okay, so back again to this is that you will see that you have the interconnection of dot diagram like this. Okay, and when you have something like this, if it is so you see that chapter 1 is question 1 in the final exam, and chapter 2 is question 2. So if question 2, if you have something like this, then you know that you need to write the equation YT. Okay, for this case is that you have X T. Remember you have XT also here. XT kan in the front here. It's also a signal. It doesn't mean that it's just a step signal. Maybe it's a complex signal. So you have XT. Then you actually convolve with H. For example, I'm calling this whole thing HT. Okay, and HT is comprised of H1 convolve with H2 convolve with H3. So how you write this out again is that you have XT star, okay, asterisk there, H1T, make sure that asterisk is means that convolution, H2T, and you have another one, last one is H3. Okay, so this is how later on, okay, for the convolution is that you need to calculate it. Okay, and do it one by one. As mentioned in a previous last class, is that you need to do it one by one. You can actually do it all together when you do convolution. First is that how you do convolution is that do this convolution first. X convolve with HT. Next, okay, do it in sequence. Next is that HT convolve with oh sorry, not that one. Not that one. Okay, you have the first one is that XT convolve with HT. Okay, the one I color code it. And then you have second one is H1T. It doesn't mean that H1T lah. You already done this. Okay, you already done this. Then whatever that you get over here is need to be convolved with the second signal. Okay, so and then next is that whoa, what's happening to the pointer? And next is that you have let me see the whole thing here, convolve with this one. Okay, so if I were to, maybe it's a bit confusing, maybe. Okay, so I'm going to draw that out again. And so I will write it like this, XT. Okay, you already convolve with H1T, so I'm going just to rub that off. So you have X convolve with H1. Okay, like that. And then next is you do the convolution H2, right? Okay, so this one, it means that this block will become this. Okay, and then you have H3. And then this is Y. Okay, so it's later on. So the one that I color code the yellow part just now, the yellow part is actually this one, this signal. You know, you see that you get the convolution. You get one signal first, and then next you convolve this whole thing with H2. After you did it, then this block will be more simplified again. It will become X. Okay, the convolve with H1, convolve with H2. Okay, and then this one is H3. And then output Y. Okay, so that one is the one I colored in this signal. Okay, and then lastly is that you will get the last signal whereby you will get, oh, no space here. And lastly is that you will get XT convolve with H1, convolve with H2, convolve with H3. Okay? So it become like this. So you will get Y in terms of this whole thing. Okay? So that one will be the color coded as this signal lah, the whole thing. So that is what I'm explaining about this interconnection of block diagram and calculation using convolution if you are given a block diagram. Okay, so hopefully you can understand that if you're given block diagram like this, then you need to do the convolution. You are not going to in the question they are not going to give you this equation. You need to write it on your own. Okay, so that will be on chapter 1 and chapter 2. Okay, now I'm going to explain on chapter 3. Okay. Chapter 3. Okay, can you see the screen right now? Boleh nampak Okay, okay, right now I'm sharing two screens. Is it okay if I share it like this? Because I want to discuss what the summary on the left side here and the slide that you have with you. Okay, so in the summary for chapter 3 is that, okay, okay, the continuous time signal. So continuous time signal, you know that in chapter 3 you learn about the Fourier series. Fourier series. Okay, so Fourier series, and you have both. You have the continuous time and discrete time. Okay, but for this, I mentioned that it's only for continuous time. There will be no discrete time. Okay, so just take note on that. You only have the continuous time. And then for what you need to focus on is to understand in chapter 3, understand how to find AK value. AK value and XT value. Okay, so what is AK value and XT value? Okay, can you see this slide? Is it too small for you? Is it too small? Okay ke too small? Tak ada orang jawab, maksudnya okay. Alright, so for the how to find the AK and XT value, okay, then you need to refer to the notes. So I'm just going to very quickly, so you see that in chapter 3 on the right side here, okay, right side here, you actually learn about the all of this, okay. And before that, let me explain a bit what is the relevancy between the continuous time and discrete time. So you have here the time domain in chapter 1 and 2, time domain. Okay, and what you learn in Fourier series and Fourier transform is that, okay, you actually convert, you are using it in frequency domain. You are using H omega frequency domain. Okay, so how it looks like is something like this. X omega, Y omega. Okay, and you know that omega is 2 pi over t. Okay, so t means the period of that signal. Okay, so this is where you have the frequency domain. And this frequency domain is where you learn in chapter 3 and chapter 4, frequency domain. Okay, so Fourier series is one of the frequency domain, and you can see that actually in chapter the Fourier transform in the video, I explained that I actually prove using Fourier series that it can be used for the Fourier transform. Okay, so in the frequency domain, okay, so what you need to do is that how to actually convert. Okay, you have the time domain, can time over here. So how do you convert to omega? So that is why you have the equation. This equation. Okay. Not sure why the tab is lagging. Okay, so this equation. So if you see this equation you can find in the chapter 3 notes on the right side. See the PowerPoint on the right side. So you go through again the slide later on the video. Okay, and you see that actually what you did was to get the Fourier coefficient. So you see that this the combine all the signal here is actually in time domain. It's like the tsunami, the waveform tsunami. Okay, you have each of the signal have a frequency, have their own coefficient, AK value. So based on that, you see in the red line here, you find out what is the frequency, the domain of that frequency. So you get that value or that domain. Okay, so based on that, okay, where Fourier series transform is actually helping you to find the coefficient of AK. Okay, so you have the xt value, which is the signal here. It can be a sine wave signal, it can be any signal as long as it's a continuous time. Then you want to actually find the AK value, because the equation for xt is that summation of AK ejk omega t. Okay, so but how do you find AK value? Is here, the equation is down here. So there are only two equations for Fourier series. This is the first equation and this is the second equation. So don't forget it. You can always refer to notes. Okay, and bear in mind, I was informed by PSTP, the one handling Euler, that during the final exam week, Euler will be closed. So make sure that all the notes, all the tutorials, whatever, the link or the YouTube link, if possible, make the YouTube link become your favorite link in your browser. Okay, so you can actually check it out later on. Okay, all the links and so on. So this, I already mentioned this like 2 weeks ago or 3 weeks ago. So hopefully by now you already did that. So there is only two equations, and based on this, how to find AK value is, if you see here, AK is 1 over T. T is the signal. So let's directly go to the example in the slide. Okay, so this one is the signal. If you see here, this is the signal given. And then we have an AK value, how to find it. Okay, and then you know that at k equal to 0 is A naught, the DC terms, and the rest will be the harmonics. Okay, so if they say that first harmonic, okay, calculate until third harmonic, means that you need to calculate until the third value for k equal to 1, k equal to 2, until k equal to 3. Okay, so this is what it means. So let's say that this one, I think you just go through the video, but I'm going to focus on this right now. You have the signal and find the coefficient. So let's say that this equation, this is very simple one. Okay, you have xt sine omega t, and then you know that you can use Euler Identity. So right here is that I mentioned that you also need to know about Euler identity. So Euler identity is given by this signal. So don't get it mixed up. Cos, Euler identity for cos theta is 1 over 2 ej omega ej theta plus e minus j theta. And sine is you have 1 over 2j. You have j beneath there. So ej theta minus e minus j omega t. So the difference is at this point you have plus, minus, and then you have the j value. Okay, so don't get it confused. Okay, so from here is that find what is the coefficient. So this one is actually really simple. Okay, need to actually run Okay, I just play this. Sure. Don't want to play the slides, so just going to remove this. Okay, so if you see here is that, okay, so from this equation, this is example a bit complex. So you have xt 1 plus sine omega t plus 2 cos omega t plus cos 2 omega plus pi over 4. From here is that using Euler, then you are going to expand it. Okay, expand it using this first equation. Okay, so you know that you can expand sine omega t using Euler, become in terms of exponential. Okay, so you are going to actually expand it, okay, accordingly using the Euler equation, and okay, from there is that, okay, you are going to actually reorganize again according to the k value. So you know that you have omega, right now you have j omega t, okay. For example, you have omega t, you have minus j omega t, you have 2 omega t, you have minus 2 omega. So you are going to assign it accordingly. So where you know that this one is at k equal to 1, okay, k equal to minus 1, okay, k equal to 2, and k equal to minus 2. So that's why you have a naught is this one lah, k equal to 0. So you have a naught equal to 1, a1 equal to the value here, okay, and so on. Okay, so this is where you can actually calculate the this AK value. Okay, so and Euler identity is also important in the case of chapter 3. Okay, and lastly is that, okay, circuit analysis concept is also needed. Of course, in chapter 3 I didn't explain that, but in chapter 4 there is an equation inside there for explanation using the application of Fourier series and transform using circuit and for application of circuit analysis. So let me just explain an example. Okay, why it's actually relevant to circuit analysis. So might be, okay, in one question, okay, a part of the question is that they ask you to find the coefficient. Okay, after finding the coefficient, okay, they ask you to find the xt value. So it can be either way. It asks you to find AK, and then next is find xt. Okay, so after that you get xt value. So this one is xt value input. Okay, so in terms of this value, and normally, okay, so when you get the xt value in the Fourier series, okay, you have xt, okay, because you did this method, find AK and xt, so you get xt using Fourier series. Okay, so this is the input and this is the output. Okay, let's see in the application of circuit analysis. Okay, circuit analysis. Okay, you know that you have circuit analysis. Normally, okay, you have voltage here, the V in. Okay, you have the resistor, the one like in chapter 4 notes, and then you have the output. Okay, V out. Okay, so you have resistor, maybe you have inductance L over here. Okay, so you know that this V is actually the input and V out is actually the output. So meaning that if I were to write this into this plot diagram, so your input is actually V. Okay. And YT is actually V out. Okay. So maybe in some of question is that, find the response of the system. Response system means that this one. Response of the system by using Fourier, by using frequency analysis. Okay, it doesn't tell you what type of analysis. Okay, so is it that using Fourier series or Fourier transform? Okay, so when you have that, you know that you have already here, you can actually convert from the time domain to frequency domain. So you can write out H, this is as V omega and this is as V naught omega. Okay, and whereby you have the response is H omega. So if it asks you to find what is H omega, so you can rewrite again this equation as H omega, okay, equivalent to what? Equivalent to V naught divided by V. Okay, so you can easily do this not in time domain, but you can use what? Now you are using the Fourier transform. You are not using Fourier series anymore. You are using Fourier transform. Why Fourier transform? Because Fourier transform, later when I summarize on Fourier transform is that, you know that you can do a convolution in Fourier transform. Okay, so this is where some of the question is going to combine between Fourier series and Fourier transform because it's in the same domain, which is frequency domain. Okay, so this one you also need to know, right? So go through this, okay, all of the notes, the video, and I'm sure you can actually try to answer that. Okay, next is, okay, chapter 4. Let me just close this. Ada ke? Yes, quite small. Oh, ada orang cakap quite small But it's very difficult for me to explain lah kalau I think later on you will look in the video kan. Nanti you tengok di video lah Okay. So but anyway, this was just the left side is a summary. My summary. You do your own summary if possible. Don't rely on my summary alone because maybe I just summarize it kan. It doesn't mean that it's going to come out. So you this is my summary and you can go through it, but bear in mind that you still need to go through the notes. Okay. So chapter 4. Chapter 4. Okay, this is small. Yes, I know. But go to the PowerPoint in chapter 4. Okay, don't rely on this because I copy paste. It does too many things to put in. I just want to summarize. So first of in chapter 4 is that, okay, so you have the continuous time Fourier transform. Okay, and I mentioned here no discrete time coming out. So just focus on the continuous time. Okay. And what you need to know is that the property of Fourier transform. So that 27 is actually the page. So just go through the notes lah. Okay, you go through the video, the notes. 27. So 27 means that the property. So property of Fourier transform is that whereby you are referring to the table, Fourier transform table. So example, you know that you can actually write out rectangular t over tau to tau sec omega t over 2. So this is example, okay? And then this one another example and so on. So make sure that you know what is, I think I don't need to explain again. Just go through the video. The scaling, how do you actually use the table to do the scaling, how you do the shifting, how you do the linearity. Okay, so that is one thing that you need to go through. Okay, and then the third one is that make sure you know how to refer to Fourier transform, the same thing lah. Okay, and next is convolution and Fourier transform. This is what I meant just now in the chapter 3 revision. Okay, so that one is slide number 38. Okay, so you have the input-output relationship. So this is what I write out. Okay, this one. Okay, you have it. You have something like this. You have GT. If I write it out again, okay, H omega. You have X omega. Okay, because this is in frequency domain. Okay, we have Y omega. Okay, so you see that in the slide chapter 4 is that, okay, you can actually write out in terms of convolution. This is what I mean just now. Convolution for time domain is very difficult, kan? Convolution for time domain. Do you want to, you can answer this type of question using time domain if you want, but you're taking too long. Okay, the easiest way to do convolution, to find out convolution, if it does not say that if it's asked you to do in frequency domain, then you need to use the Fourier transform. If it asks you to actually do convolution in time domain, then you need to use either convolution sum or convolution integral. Okay, so for the case of frequency domain, okay, if you are given like this, easily you should be able to find out the convolution Y omega is H omega, okay, has star by X omega. Okay, it means that, what it means here is that you just multiply H times X omega. So when you do that, maybe you find out that maybe you need to do partial fraction and so on. So you need to do that. Okay, and then later on you get what is the Y omega. Okay, so go through the slide. Okay, I'm not going to go through it because it's all there in the detail. Okay, and of course, last but not least is that the application of circuit theory. Okay, you go to this examples, application. If you see here, application, same thing lah, what I mentioned just now. So it can ask you, obtain the frequency response of H omega. So this one, it assumes that you have the voltage out is V at the end here and VR is V here. So find out what is VR over V. So sometimes you might need to use the Kirchhoff voltage law. You need to use the voltage divider. Okay, you need to understand how to actually derive the equation when you have a series of parallel circuit or summing circuit. Okay, so my suggestion is that, okay, this is where students need to understand that lots of our subject, okay, under mechatronics or even electrical is not stand-alone. Means that you only take BEKC2433, then you don't need to learn about other things. It's not related. No, it's actually this subject, when you make an application, is related to the circuit theory subject. So if you have circuit theory notes, then go through it again. I hope that you didn't just flush it out down the toilet, okay, or throw it out. You should save it until the end of you finish UTEM. Okay, don't give it away to your junior and so on. You should keep it so that if you want to improve yourself, you want to maintain a grade A, then you should have that along with you. So this is example, just that I actually this is a revision sebenarnya. It's not supposed to be teach again in the subject. We understood that you already take this during circuit theory, okay, 1 and 2. Okay, so just go through and look at how actually the implementation of this the equation. Okay, so example, this is, I think we are given you few example. Example 9 is that how do you actually get the equation, okay, if given IT. And then equation example 10 also, SSS 6 also same thing. Okay, so just go through that, and even in the past final exam, the example is that it's given inside here. Okay, you have a circuit and find the frequency response and solve for the voltage V out. Okay, so I'm sure you did that previously when I asked you to submit. Okay, and that one is on chapter 4. So next is that, chapter 5, okay, because I don't want to take too much of your time. Most of you guys, you're also quite busy to study. Okay, not only focusing on my subject only. So not much. Go and study after this. Okay, so chapter 5 is that. Okay. Right. So first, what that you need to know is that you're able to transfer discrete time signal into an equation. So you have learned in chapter 1 discrete time, kan? Continuous time. You learn about the discrete time signal lah. You learn about the discrete time signal, right? You have and then you learn that it can be shifting and -1 and -2 and so on. So here is that you need to be able to actually write out the equation. So this one is referring to slide number 15. Okay, 15 here. 15. Okay, here, 15 example. So you have this example. Okay, so you see that this one is actually referring to chapter 1, kan? This is chapter 1 on discrete time signal. And you see that, oh, there's a shifting. You have 0. At 0, you have amplitude 1. At 1, you have amplitude 1. At 2, you have amplitude 1. Until 4, you have amplitude 1. And the rest is 0. Okay? So how you write this is that it's as normal that what you did before. So how you write it is that xn equivalent to, you know that you have 1. So you have xn. Sorry. Oh no. Sorry. So your amplitude you have 1. So I'm going to write the n. Okay, n saja. Plus n minus 1. Okay. Plus n minus 2. This one kejap why is the mouse you have xn. Maybe I shouldn't write it, but anyway, xn plus xn minus 1. You have 1, 1 plus xn minus 2 plus xn minus 3 plus xn minus 4. Okay, and the rest is 0, right? So you have this. Okay, so if you see the equation, so you see that second one is that you need to convert the discrete time signal to Z transform. So this is where you need to refer to the equation of Z transform here. Okay, which is you can refer to the notes in the notes over here. Okay, but directly you know that you can able to transform it. Okay, by actually Z equivalent to xn value is 1. Okay, so Z minus 1 plus, you have 1, so Z, this one is no shifting, set Z0 lah. So actually this is equal to 1, plus Z minus 1 plus Z minus 2 plus Z minus 3 plus Z minus 4. Okay. So this is how you convert it using this equation. So xn value is this value lah, dia punya amplitude. Okay, and then minus n is whatever. Do you have a shifting there? So minus 1 and so on. Okay, so this is how you need to understand how to convert that. And then make sure that you know how to actually refer to tables. So there is few in example here, I explained about how to use the table, kan, refer to table Z transform. Okay. Okay, refer to table Z transform over here. Okay, yang this one. And then also for this one, the right-sided sequence and so on. So you have here, refer to, you just refer to the appendix that I allowed to you learn. So make sure that for each chapter 1, 2, 3, 4, 5, you have the appendix, especially chapter 3, 4, 5. Appendix for the table, Fourier series, Fourier transform, and Z transform. So make sure that you download that and if possible, just print it out. If you have a printer, print it out. If you don't, then just download it. Okay. So, know how to actually use the table, because the table is really important in Fourier series, Fourier transform, and Z transform. And then I know how to use the partial fraction. So if you go through the later on in the example, like example 4, you know that later on you need to do the partial fraction. Okay, partial fraction. So this one, especially in the inverse Z transform. So you're given an example of this type of equation. So find the partial fraction. So you're going to do the partial fraction. How to do it? Then make sure you do it. You actually practice many times. Okay, don't only limit yourself to my notes. You can go and download from internet example. You can go to YouTube. Lots of example of partial fraction. How to do that? Okay, if for example partial fraction for Z minus 1, how do you do that? If Z to the power of minus 2, how do you do that? Z to the power of minus 3, how do you do that? So go and find out how to do the partial fraction when you have increased number of power. Okay. And lastly is that understood how to actually plot the region of convergence. So region of convergence is important to be plotted and by referring to table. Okay, so if you see example 5 here, is that after you find out what is the region of conversion, okay, normally, okay, if you see determinant stability, so you know that this is the equation referring to the table. You know that 1 over 1 minus Z to the power of 1. Okay, you see here, these two have similar equation, but the difference is that the region of convergence. Okay, one is Z more than 1, one is Z less than 1. So if for more than 1, then you are going to refer to which equation? Okay, so you are going to refer to this one. Okay, so that's why when you plot it out, you have 1 over 4 and 1 over 3. So for this case, that your answer is you need to draw out the region of conversion. Okay, so so go through this one. I think in the video it's much more detailed because this is static slide. So go to the video and watch the video that I shared. Okay, so that will be the summary for chapter 5. Okay, so in summary for all the chapter 3 and 4. Okay, chapter 3 and 4. Okay, as mentioned before. Okay, chapter 1 and 2. 1 will be covering question 1. Question 1. Okay. Chapter 2 will be covering question 2. Right? Next, question 3. Okay, will be a combination. It's not either Fourier series or Fourier transform. Both are coming out in question 3. This is where I mentioned just now. Either in the first part is that it asks you to find out Fourier coefficient. Then next is that to find out what is the output or the response using of the system. So you need to use Fourier transform. Okay. So combination of Fourier series and Fourier transform. And lastly is chapter question 4 will be covering chapter 5. Okay. So I think that will be all covering for the revision. Okay, at least maybe by now you've forgotten about chapter 3, 4, and 5. Okay, chapter 3 and 4 especially. So make sure that you go through the video, watch again. Okay, don't make a mistake that last time you watched the video for chapter 3, 4, and 5 was during that time, during week 10, 11 that you watched. After that, until final, you didn't watch again. Okay, if possible, watch it minimum 2 times. Okay, 2 times and take notes. Don't just watch without processing it. Okay, the tips is to excel in any subject is that when you watch something, write out. Write out directly on a piece of paper and make your own notes. Okay, so if you don't process the information, then it won't stick to your head. Okay, it won't stick to any paper pun. Okay, so you don't have time later on within the 3 hours exam to browse through all of the video. Impossible. One video is about 3 hours. Okay, 3 hours or 2 hours kan for each class just at that time. So you cannot do that. Impossible. That's why students fail during the online exam ni most of the time, because students don't take the chance to actually study beforehand. They thought that the online exam is easy because you can refer to anything. Yes, you can refer to anything. But the trick of the online exam is not easy topics. Lecturer make the question so that you don't have time to actually refer to notes. You only refer to what you are in your head. Okay? So if you don't study early, you cannot answer the question. I'm sure you cannot answer. So don't do the mistake of not studying before exam. Okay? So I think before I'm actually at the end of the topic. So of the class. So before we end, can I ask you, because we end of the class, can we take a photo on your camera if possible while waiting for the other student to on the camera? The rest of the student, please go to the feedback form here. Okay, answer the question, a very quick question. Okay, so it's about the class that I actually conducted during this one week. During the whole semester. And I would like to apologize if anything I was angry or like high pitch voice or something. Okay, yelling in the screen. But sorry about that. I'm always high pitch like this. So, but what I want is for student to understand the topic. That's why I'm really insisting that student make sure don't do the mistake of not studying. So, go to Euler, okay, Euler, and answer the question. Question is very simple. Is that from week 1 to 15, which is today, what do you like and dislike about the implementation? Means that what do you like about the class? So I want to know what do you like and what you dislike about the class. Maybe I'm not sure what you dislike. So you can write there if any. But if no, then just write about what you like about class. And then you can explain long paragraph. It's okay with me. And then rate my teaching for this semester. Either it's okay 1 to 5. Okay, so rate that. And then this one just a question, quick question. Will you be interested to have me as a lecturer in future subject? Well, maybe yes or no, okay? So, oh sorry, that one I think need to change it. So, that one is I think I need to change that question. Wait. Okay. Okay, I think should be okay now. Okay, so yes, no, or maybe 50-50. Maybe lah. Okay, maybe tak nak jumpa saya lagi. Okay, tak apa. And based on the topic that I have learned, my target grade. Okay, what is your target grade? I know that when you fill in the teaching evaluation form, you were asked what was your target grade. I actually didn't know that student actually fill in that. So what is your target grade? So that I know, I can estimate. Then make sure that target grade is based on if you study, If you study and you target to study now and get 8 good grades for this subject. So I actually really confident for student. If you really follow the class, okay, even though it's a synchronous class, but actually the topic is already detailed in that synchronous video. So you can just rewind and rewatch again the topic. So can student please fill in this, and while opening camera, let's open the camera. Tak open lagi. Boleh open camera? Buka kamera lah kejap. Saya nak tengok muka-muka yang ada berapa orang ni aja yang hadir. I think this one is the normal student that come to my class lah, 22 orang Memang 22 ni sajalah yang datang kelas kot. Last revision pun sama juga. I think. So ni siapa? Chan. Okay, Chan. Un, hi. Hi. Ni Zihao
Hai, tadi pun Tan.
Oh, Tan. Ni Haikal. Okay, Haikal. Yang banyak tanya soalan juga ni, Haikal kan? Yang lain, Arina, yang perempuan girls takkanlah tak ada tudung yang sarung kan? Kat rumah ada tudung sarung kan? Pakai je, saya pun tudung sarung je. Chan. Ni Chan siapa dia? Pada Chan ni ada siapa Ada 2 orang tu. Chong. Ada kamera? Chong Jia Sheng, Chong Jia Kuan. HP ni saya tak tahu siapa. HP. Oh, yang ni ramai-ramai Justin ni. Ni Justin ni ramainya. Berapa orang ni? 5 orang. Tak dengar Justin.
Halo.
Hello. Berapa orang tu Justin? Rumah you?
4-5 orang saja.
5 orang je. Ya ke? Kalau rumah 2 tingkat selalu lebih dari 5.
Adalah.
Ya.
Tak sama dengan.
Oh, ya ke? Ni siapa? Zihao. Yang lain mana? Jeslina Un, Kohzia, Haikal, Ridwan. Tak ada? Okey, kalau tak ada ni je lah kita ambil gambar. Cepat. Sebelum semua nak study kan? I'm sure everybody want to study for subject. Ada exam coming soon on Monday. Oh, okey. Ni siapa? Nura Natasha. Okey. Nampak pun muka comel. Siapa yang lain? Tak ada? Okey ni je okey. Okey, 1, 2. Siapa ni? Muka tak nampak lah siapa ni ZH ni. Muka you macam silau-silau. Tak nampak. Okey? 1.
Bagus lah betul.
Okey, tak apa. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, that's all for my class for this semester. Make sure that you fill in the feedback form so that I think that one is very good for me to increase my next semester classes Okay, any last question before I end the session? Put the notes in blender and drink. Haikal cakap put the notes in blender and drink it. Boleh jugalah try kan. Okay, the revision just now, the PowerPoint, I will send it to the Telegram Okay, so the revision, the notes just now, PowerPoint. Okay, anything last thing? So make sure that I will make sure that you fill in the feedback form and wish all the best to all students for final exam, not only on my subject but for all other subject. Good luck Hopefully you study well. Target lah. You know that normally if you want to target something, good grades, you need to target B plus and above. You target B plus, then normally you get a little down there, B or B minus. Okay, but if you target A, you might get A and minus and B plus. So target higher Okay, that's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
You Doctor.
Okay. Okay, sama.